Hello everyone. We have a question which says that point A and B lie on the curve. Y is equals to x square minus 4x plus 7 is the equation of the curve. Point A has coordinate 4 comma 7 and B is the stationary point of the curve. Okay. The equation of the line L is y is equals to mx minus 2, where m is a constant according to the first part of the question. In the case where line L passes through the midpoint of AB, but we don't know the coordinates of B, so how can we find the midpoint of AB? According to the question, the line L passes through the midpoint of AB. Find the value of M. So definitely for that, first of all, we have to find the midpoint of AB. Then we can find the value of M. But we just have the coordinates of point A. We don't have the coordinates of point B. So we will find the coordinates of point B. Because the coordinates of point B are basically the coordinates of the stationary point. So in order to find the coordinates of the stationary point, we can go for using x is equals to minus b upon 2a. With the help of this, we could find the x coordinate of the stationary point. Minus b upon 2a means minus b, and the b is negative 4 upon 2 times a, and a is the coefficient of x square. So placing the value of b as negative 4, placing the value of a as 1, we can simply get the value of x as 2, which is basically the x coordinate of the stationary point. Place this value of x in the given curve equation, get the value of y after simplifying it, and we got the value of y as 3. Now we can say that x is equals to 2, y is equals to 3 is basically the coordinates of point B. We can write b is equals to 2 comma 3. So finally we have got the coordinates of point A and point B. So by using the midpoint formula, we could get the midpoint of AB. So just add both the x coordinate and divide by 2, and add the y coordinate, divide by 2, and finally 3 comma 5 is the midpoint of AB. According to the statement, the line L passes through the midpoint of AB. That means this 3 comma 5 is basically a part of the line L. The equation of the line L is y is equals to mx minus 2, and this line passes through the midpoint 3 comma 5. So just place the value of 3 comma 5 over here. Instead of x, write 3, instead of y, write 5, and rearrange it, and finally get the value of m, which is 7 upon 3, which was the requirement of the question. In the first part, find the value of m, and finally we have found the value of m as 7 upon 3. In the second part, it said that find the set of values of m for which the line does not meet the curve. This time the condition that they have given is does not meet the curve. They are talking about the curve and the line. So the very first thing that we have to do that is get the equation of the curve equal to the equation of the line, like we have done over here. Rearrange them so that they could be properly converted into a quadratic form. So x square over here minus 4x, this mx over here minus mx, x is common in both, taken out, minus over here, and in the bracket 4 plus m, and this 7 minus 2 over here plus 2 is 9. This is a proper quadratic form in the form of x square, x, and a constant. Condition was does not meet the curve. So does not meet the curve means the discriminant is less than 0. So definitely we will use the discriminant less than 0 and place the value of a, b, and c. From here a is 1 over here, the value of b is negative, and 4 plus m in the bracket with a square b square. The value of c is 9 over here, and does not meet, that means less than 0. Simplify the given, negative square is positive, use the formula of a plus b whole square, which is a square 16 b square plus a square plus 2ab plus b square and minus 4 times 1 times 9 is minus 36. Rearrange them and you can see a proper quadratic equation in the form of m is made. The question said that find the set of values of m, and definitely we have a quadratic equation in the form of m, and definitely whatever the set of values would come would be the values of m. So first of all, just use a quadratic equation and get the x-intercept, and over here x-intercept is basically represented by the variable m. So use the quadratic formula, place the value of a as 1, b as 8, c as negative 20 in the quadratic formula, and get the two values of m, which are 2 and negative 10, because they are basically the x coordinates, because the variable used is m, so definitely we are writing it as m. The coefficient of m square is positive 1, therefore if we draw a sketch it would be a curve, a u-shaped curve, because the coefficient of m square is positive, and the m, which is basically representing the x coordinates, they are 2 and minus 10, so 2 over here, negative 10 over here, and finally the inequality is less than 0. Less than 0 means negative, and negative means negative y, and if it is negative y, we need those values which would result in a negative value of y. And if we look at the graph, we could easily say that if we take any value less than 2 would result in a negative value of y, and if we take any value greater than minus 10 would also result in a negative value. So all the values less than 2, as I have written m is less than 2, and all the values greater than negative 10, as I have written m is greater than negative 10, are the set of values for the given second part of the question.